I hope all of you still can see my screen.
Yes, we can still see your screen.
Yes, so in lecture materials, if you see, we have covered all the OS portion. And don't worry, we will do revision again. So I'm going to cover the introduction to networking. There are 4 topics under networking, 3 topics mainly, and then we will continue into revision. And then we have some videos that I have uploaded. There are 2 types of videos here. One is connecting to the MS Team, the other one connecting to the YouTube. 2 options. Either you want to see the one connecting to MS Team or YouTube, up to you. Uh, so you have option to watch. So what I'm going to do today is I'm going to cover this topic, Introduction to Network and Operating System. It is quite a huge topic, but don't worry, it's all again basic, quite basic. Before we go into details, and at any point of time, if you guys need any further clarification or explanation, let me know. Then I'll go into the detail. Otherwise, I will try to cover what is required only for this subject, for your exam. So with that, let me start. Moving on to the next slide. Most of these, as you see, will be quite basic. So I'll run through the slide quite fast. Unless if you have a question, please stop me, because we have only time until 4:30. Like what I mentioned earlier, I will stop at 4:30, meaning like 1 hour from now, and then I got a meeting with EOG. Okay, network means where uh, devices. I'm going to call it devices because remember I told you guys there's no more computers. Those days only computers are connected together. Now every single devices, or we call it Internet of Things, isn't it? IoT. It can be anything, sir. That's why they call it Internet of Things. It can be PC, it can be laptop, it can be phone, it can be human being, with all kind of devices that anyone holds. It can be even cars, because all your cars, luxury cars today comes or equipped with Internet of Things. That's why you see the cars on the traffic on the roads, or buses or lorries, all are connecting to the GPS, connecting to handphone, communicating to each others, or even high-speed trains, all are fully equipped with systems. So this is what we call networks, yeah, internationally connected devices. So today's lecture we will cover a number of topics, including fundamental of networking, terms like packets, protocols, network devices, peripherals such as NIC, network interface card, modem, hub, switches, router, bridges, all will be covered, but not in very detail. Yeah, not in very detail. We do cover communication channel characteristic because there are various channels to communicate, different types of network, LAN, MAN, WAN, and so on. We also will cover some network topologies and their properties, physical and logical topology as well. So why do we need a network? As all of you understand, without network, we cannot communicate. So in order to communicate, yeah, from one end to the other end, we need to communicate. So how we need to communicate? There are various ways to communicate. That's why we need a network. And network without resources, it doesn't work, or it's meaningless. So we need a lot of knowledge how to use your devices, files, printers, manpower, and all need to be shared. We need to know how to share, how to assign sharings, and so on. Of course, there are a number of disadvantages as well, which we will cover along the way. Some are very general, as you all know. We run into viruses issue, scammers, and so on. Yeah, we can discuss about all that. Mostly all are related to security. Model of a communication network. A lot of this slide, you will see that it just refreshing slides, that you need to do either self-study or you need to prepare yourself. It just tells you what are the topic, what are the areas that you need to cover in order to prepare for the exam. Yeah, so that's what we will run through the classes. And then if you feel that you don't understand any part of the topic, please go do some self-study or come back to me. I can explain further clearly. If you just keep quiet, I assume that you understand. Okay, terms like host or node. I hope all of you know host or node could be a client or server. And then there is a protocol, yeah? Various protocol that we have discussed even earlier, or we will continue to discuss under introduction to operating system as well as introduction to network. What are those protocol? Please recall, without all this protocol, network or communication does not take place. And then we have a network interface card, NIC card on both ends for the channel to communicate. For example, when you send message from your phone to the other phone, your phone is a host or node, and then your phone has a interface card, or we call it network interface, and it communicates with the channel, for example, either through your service providers or through Wi-Fi or through cables, communicating or connected to the other end, and on the other end there will be a network interface card or another receiver in order to receive your message and convert it into a format that readable by the receiver, and vice versa. That's how things work. Yeah, that's how communication works. Some of the protocol that you should know that we have covered during your diploma level or lower level is such as HTTP, Hypertext Transfer Protocol, Hypertext Transfer Protocol Secure, File Transfer Protocol, FTP, Simple Mail Transfer Protocol, SMTP for mailing purpose. TCP/IP is a very critical, important protocol. Without TCP/IP, you cannot use internet or no networking. UDP, Universal Data Protocol, yeah, for broadcasting. TCP/IP more for one-to-one or very dedicated, and UDP is for broadcasting. All right, so we have discussed all this in very detail during your diploma level. NIC card, communication channel, and protocols are the key words that you need to know here. Again, you have another slide. If you do not know what is protocol, protocols are basically guidelines, guidelines or instruction. For example, what to do and what you cannot do over the network for two communication or two hosts to communicate, to transmit or receive a message. How long is the message? Which part of the message is actual data? Because as you know, message comes with header and trailer. Header will have some data, trailer will have some data, and then the actual data is in between. So protocol governs all that to make sure the data that you send to a very particular, very specific receiver will receive it, not anyone, not anyone. So all those details on what you send and what you receive is governed by the protocol, which we have covered in very detail, I believe, during your earlier studies. Communication channel, we have computers or devices, we have cables and radio signals. which are still under analog. Modem, of course, we don't use it anymore, but the term is still being used, which is a abbreviation or short form of modulation and demodulation. And then we also will cover network devices such as hub, switch, router, bridge, and a few other devices. Sending files and messages, very basic, like what we discussed in a couple of weeks, how your messages will be transmitted from text into binary and vice versa, and how the binary text, the 0 and 1 will be converted into electrical signal. As you can see the example, if you have 0, 1, 0, 0, 1, 0, 0, 0, it will be converted into electrical signal. Wherever there is a 1, there will be a pulse. Wherever there is a 0, no pulse. This is how the system, the computer system will understand. There is a current or there is no current. If there is a current, for example, 5 volt, then there is a data 1. If there is no current, that means it will be flat, 0. This is how the computer system will understand there is a data that need to be carried. So there is no such thing that the computer system can understand your 0 and 1, but what the computer system can understand is all 0 and 1 based on whether there is a current or no current. So these are very basic information which I'm not going to spend any much time discussing about it. I hope all of you understand this and please go through it on your own. Messages, packet, what is packet? A group of related packet make up a single message. That's what we call packet. Packet of messages or group of messages. Packet header, every packet will have a header and trailer, like what I told you earlier. Guys, I assume a number of topics here that you have covered during your diploma levels or lower levels. If you think that you need me to go through into more detail, clarification required, please stop me. Otherwise, I'll run through quite fast. Reason, like what I told you earlier, it's quite a long lecture. Yeah, there are quite a number of slides that I need to cover. If I go through into a very detail for every slide, I don't think so we can finish it. Advantages of packet: to simplify operation and increase communication efficiency. Please take a look at dedicated connection and so-called non-dedicated connection, or we call it connected and connectionless. So you will understand what is the difference between these two. Channel characteristic, communication channel, what are the channel, what is link, bandwidth, medium, guided, unguided, UTP or STP. So all these are very basic. So I hope you do some revision and take a look at all your old notes if you have forgotten. Multi-link channel, where you have various routes to get connected. For example, if you look for information from US, there are multiple routes that you can access the information. For example, you can go through the router from Kuala Lumpur to Singapore, for example, then Singapore connected directly to US, or maybe the other route is KL to Bangkok, Bangkok to somewhere else and to US, or to Tokyo and somewhere else to US. Whichever route is available, whichever route is shortest might work. Yeah. So we cannot decide. All that will be decided by the system. Will be depend on the protocols, depends on the bandwidth, depends on the traffic, that how it works. DSL stands for digital subscriber line, quite an old communication channel, has been replaced by many more advanced or newer channel. Okay, still continue with data transmission or channel characteristic, point to point or multi-point. Ethernet, definitely Ethernet is very important. Please pay attention to Ethernet. Other than Ethernet, we did cover interfaces or communication channels such as Bluetooth, WiMAX, DSL, cable, satellite link, telephone modem, Wi-Fi, and so on. And also don't forget, you must know what is simplex, half duplex, and full duplex. All these are very basic, basic stuff. So when come to network topology, it is not new for you again. Very sorry, because most of the stuff here, like what I said earlier, are very basic. Just refresh. We will cover fundamental layout of a network. And also we will cover logical topology and physical topology. What are the differences? And I will give you some examples. When come to network topology, there are various network topologies. Mesh network. Mesh network means it's a combination of one or two. Sometimes we do call hybrid. Bus topology, very old method. Hardly you can see any devices are connected through bus topology anymore. It has its own advantage and disadvantage. Star topology and ring. And you must know which one the one we use today, which is still being used, still being what we call reliable compared to the rest. So, well, all of you must be very familiar with these topologies, should be able to draw, should be able to label it properly, should be able to explain clearly how the host and the node, or what we call client server, communicate through the different channels, characteristic. All of you should be able to write in detail how is the operation of these topologies. If you're not very sure, please read the next couple of slides, understand it, and you should be able to upgrade or make yourself clear, on this. Again, like what I said, I'm not going to go through into all this detail unless if it is new for you, please stop me. Otherwise it will be very boring if I cover all this into very much detail. So we have bus topology here, very old method, very unreliable, very low speed, very cheap, and being used those days and not in practice or not being used anymore in today's world. And there are many reasons to that which you should know or which we have discussed. Bus network implementation, please read through on your own. Star topology is still being used until today, very popular, very reliable, and you should understand how it works and what are the devices are being used for star topology. We will come back to this into our discussion at later stage. But for now, make sure you understand the topology itself. Ring topology, mostly connected from point to point in a circle format in a ring. There is advantage and disadvantages. And also you need to know why ring was used those days. Not very popular today because of the unreliable or the disadvantage of this ring. But there are some still old companies or old setup still running on ring. Mesh hybrid is quite popular as well as of today. It is like a win-win situation. What will happen is when company get merged or company acquire another company, when they decide not to change the entire network, they will just combine the two infrastructure or the two topology into a new topology, which we call it hybrid or mesh. There you will see various types of topologies, yeah, being merged or being combined, running as one network. Yeah, so that's where you ended up with mesh topology. So this is an example of 5-node full mesh network where you have ring and star, yeah, combined together. Physical and logical, make sure you are quite clear with the term, what is physical and what is logical. Physical is the actual interconnected wires and cable, yeah, the actual network, the physical network, whereas you will see completely the opposite on the logical, yeah. Physical, as you understand, is you can see, you can touch, you can feel it, the actual network. That is what we call the physical. Logical is basically on the paper. It is just a design, virtually designed or designed using software before the physical is being implemented. So normally during the work, actual work, what we do, we come out with a logical design first or logical topology, then we will migrate into physical. Yeah, that's how it works. Okay, an example of topology, logical topology, and later we will put this or implement this as a physical star topology. Connecting endpoints through links and networks. I'm very sure you guys have done this kind of exercise where you are trying to connect various local network into one large network or huge network. So you might ended up using number of switches, number of various types of topology to make the entire network works. So when you have the entire network works for a building or for a number of buildings or for a local office, we call that local area network. Yeah, local area network. I'm very sure this is not a new term for you. Typical home network. Today's home, as all of you is aware, your home network is also quite complicated, quite advanced, because you might have 10 to 20 devices connected to your home Wi-Fi. For example, you have your TV connected to your Wi-Fi, your phones are connected, your laptop, desktop, yeah, and maybe a few other devices, gadgets if you have, yeah, watch, for example, all are connected to your Wi-Fi. So that's what we call typical home network. You just need to think about either they are connected through wired or wireless. Yeah, so this is an example of basic Wi-Fi, local area network, wireless Ethernet, yeah, or we call it Wi-Fi. Following Ethernet standard, I hope you understand the difference between Internet and Ethernet. We are not talking about Internet now, we are talking about Ethernet. Ethernet is Wi-Fi based on 801.1 or point, depends on the Wi-Fi type. Backbone network, for example, if there are two LAN, how the two LANs are connected through the backbone. And most of the time we will be using fiber, isn't it? So that is what we call backbone. As you can see the diagram here, there are 3 local area network with 3 switches connected at the local site, connecting to one main switch over here. And then the main switch is connected to the server. This is internal, could be the organization itself, and the entire organization is connected to the outer world through the router or what we call gateway, yeah, gateway. Then moving higher level, we have metropolitan area network, bigger or wider areas. And sometimes within the metropolitan area network, what we will have is what we call campus area network. Yeah, slightly smaller than the metropolitan area network, but larger than the local area network. An example of MAN, metropolitan area network. Take a look at the detail, yeah? Spend some time maybe over the weekend, go through these slides. I will not be able to go through into every detail unless there is a question from you. Otherwise, I assume that all of you are, yeah, quite familiar with all this basic stuff. Wide area network, make sure you understand what is wide area network, WAN, extranet. Also, make sure you understand what are the differences between intranet, internet, and extranet. Ask yourself questions. Make sure you ask yourself questions, and you should be able to answer all those questions. What are the differences between internet, intranet, and extranet? Network devices. There are various network devices which we can run through quickly. I'm not going to go through into very detail unless there is a question. We have various devices for the end user, or call it host, and also connected through the NIC and network device, actual network devices. And you can see some of the examples are popping up here. Computers, scanners, printers, NIC card, and network devices, such as hubs, switches, routers, and many more, Okay, some of the repeaters and hub. Okay, before I move on, let me check, make sure all of you are with me. Otherwise, I'm the only one talking. I really don't know whether all of you are with me or not. Let me ask you a question. What is the difference between hub and switch? Now, before I go further, even though the topic here is repeaters and hub, what is the difference between hub and switch? Let me check how many of you can type at the chat. The difference between switch and hub. Anyone? If you still remember what we have covered during the diploma level, give me the answers. Okay, I have one answer. Switch connect various devices together on a single computer network. Hub not doing that, is it? How differ is hub? Hub allows to connect multiple PC while switch connect devices together on a single computer network. To me, both the answers look the same. Okay. Hub is passive device while switch is active device. All right, that is acceptable. Multiple PC to single network. Both PC and hub doing that, multiple PC to single network. Both hub and switch can do that. No difference. High security and low security, not really. Hub operates on physical layer, switch off. No. That is not the answer. Anyone else? Anyone else? Please try. What is the main difference between switch and hub? Hub is a networking devices which is used to transmit the signal to each port to respond from which signal was received, while switch is a network device which is used to enable the connection. Not really. Hub is a networking device that allows you to connect no. Okay. Thank you for all the trying. Thank you for all the trying. Thank you for all those responded. Appreciate it. Okay. I'll come back to this discussion shortly. Shortly. Let me go back to my presentation. Okay, before we go into the switch and hub, let's take a look at repeaters and hub. Early network didn't use interconnecting devices. Yes. Earlier in the 90s, early 90s or early 80s, where the network was introduced to the world, either two devices are connected together, or just one or two, or the devices are alone, as you all know. But as the demand increases, more people want to communicate, more people want to send messages, then there was a need to link or to communicate more devices. So that's where telecommunication companies such as the earlier companies, HP, Hewlett Packard, IBM, Motorola, who else? Cisco, the earlier players on the networking. This company is also important. Digital. The company is no more here, no more exists. We call it Digital. Later replaced by HP. Company which I mentioned earlier, they see very good demand for people to communicate from different locations. Then they started to develop network devices. Network devices. So company like Motorola, company like early Siemens. Now I need to recall all the old companies. Not the companies that we have today. Some of the companies are disappeared. Siemens. Some of the companies are still here, but they are doing different business. These old companies, some are still, of course, exist, like Motorola, they are still here. Siemens, some other companies, old companies. There are some big players in US, for example, AT&T, Cisco. All these companies, they rush into building network devices, such as repeaters, such as hubs, because they see there is a huge demand for networking, which we are going through now. There is a huge demand. There is a huge demand for networking at that particular days. The same goes like what we are going through now. There is a huge demand for AI, artificial intelligence, and cloud computing. So we went through the same thing during those days for network devices. So when they can connect devices, but with limited choice, then they see the signals or the quality of the signal drop over the distance. Then they wanted to come out with some other devices which can so-called recharge or reboost or retransmit the signal again. That's why they came out with devices such as repeaters. So remember I told you the limitation earlier was in terms of total cable length. In terms of number of computers or devices can get connected. Okay, let me ask you a question for those who still can remember. I don't know about other sites. I'm very sure all of us covered the same syllabus. What is the distance that your CAT cable, category 5 or 5E or CAT 6, or in general we call UTP cable, isn't it? UTP cable. What is the general or distance that the UTP cable can cover? Anyone? Just type. Or we call it CAT 5, CAT 5 or 5E or CAT 6. Cable can cover. The distance. Anyone? I got one answer, less than 100 meters. What about the rest? Only one answer so far? Less than 100 meters. Anyone else? Okay, I see some answers now. 100 meters max from Stanley, more than 100 meters and less than 300 feet. Okay. All right. Generally, it's 100 meters, huh? 100 meters. So 100 meters is not such a long distance. If you have your data center in ground floor or floor 1, and then let's say you're sitting in floor 15, I think that is more than 100 meters. How are you going to connect your boss who is sitting at top floor, level 15, and your data center is in level 1 or first floor? Not possible, isn't it? Because your cable only can cover the distance of 100 meters. Then what happens if anyone sits more than 100 meters, which is quite common nowadays, isn't it? So that's the reason why they came out with devices such as repeaters. Repeaters. So what repeaters will do is, repeaters will repeat or retransmit. Retransmit the signal. Repeater enables you to connect computers whose distance from one another would make communication impossible. For example, here you see this device and this device. If they are more than 100 meters, you put a repeater in between to connect. A repeater extends the length of a network. The repeater actually retransmits the signal so that it can travel more than 100 meters. Or sometimes you call words like regenerate the signal to its full strength. Is something like your phone. You go further into a rural areas from the antenna or from the hotspot, it get weaker and weaker. Then you need another booster or so called repeaters or a device that retransmit or re-energize the signal so that you can hear it clearly. So the repeater works in the same way, right? So repeater, again, like what I said, is a very old device. In today's world, we don't really use repeaters. because in today's world, we have many other devices which has replaced repeaters. But that's how we started our networking world, networking knowledge. And then quickly we move into Ethernet, where, as you all know, Ethernet hubs, Ethernet hubs support multiple ports, and the repeater is kind of built in inside the hubs. So you see now hub has taken over the repeater's function, and hub also comes with multiple ports. And repeater generally works on hub based on bus technology or bus topology. So quite an old topology as well, like what I mentioned earlier. And one of your friend, or couple of you mentioned earlier that hub works on passive connectivity. That is very true. That is very true. So there is a difference between active and passive connectivity. Passive is like you don't need anything to be configured. It's plug and play. You on, the device will work by itself. Everything is pre-configured. It's not configurable. It's like you just on, you plug in, it works. That is passive. Nothing that needs configuration. It is like plug and play, which normally we call passive devices. Hub is like that, and hub is cheap. You can buy for 10 ringgit or 20 ringgit. You just can connect 4 to 5 devices. I'm talking about the home hub. If it's in the office, it comes with maybe 12 ports or 24 ports. And then you can just connect it without any configuration, without any setting required. It is like you just plug into the power, you on it, you can start using it. It's pre-configured. Whereas on the other side, active devices allows you to configure, allows you to program, allows you to change, allows you to do setting. That is active. So one of your answers earlier that your friend said hub is a passive, switch is an active. I agree, but that is not the answer that I'm looking for. I will discuss with you later when we discuss about hub and switch, the main difference between hub and switch. Other than that, you need to know what is bandwidth. Bandwidth. Make sure all of you know how hub is being used in the network, how hub is being connected in the network with various devices. You should be able to explain that. And also to add on, hub normally provide you quite a low speed. Maybe you only can find hub at 10 meg, not more than that, 10 Mbps. That means each port, the speed is 10 Mbps. That is hub. Again, hub is an old device, old technology, because it is based on bus, unreliable, and it's not popular anymore. It is cheap. You can use it at home. But in a company, we hardly use hub. We don't use hub. Okay. Ethernet hubs, just to discuss slightly further on Ethernet hubs, receive bit signals generated from a connected computer on one of its port. So that's how hub works. So signal will come from one of the device from one connected computer on one of the port. For example, let's say this device here. I hope all of you can see my screen. Huh? So this device here, if this device here, let's say call it device A, is trying to send the signal, it will go to one particular port. That's what this point is trying to highlight to you. Receive bit signals generated from connected computer on one of its port. Then clean the signal by filtering out electrical noise. That is what is happening inside the hub here. There will be some cleaning, or we call noise filtration, electrical noise filtration, and regenerate the signal to full strength. That means that is the job of the repeater. Regenerate. Let's say this cable here, the cable here, look at my mouse. Huh? If the cable here is 100 meters, then it is beyond the communication. So you need this hub to regenerate the signal. Otherwise, the signal cannot go to the other end. That's why the hub now plays multiple role. One, connecting all the devices together, at the same time checking the length. If it is more than 100 meters, the hub has to regenerate the signal, the strength of the signal. Transmit the regenerated signal to all ports of a computer. Yeah. So you see, even though A is sending to B, but it will send to all. It will send to all. Huh? Transmit the regenerated signal to all other ports. That is important. It transmits to all ports. If there are 5 other ports, it will transmit to all 5 other ports is connected to. Okay, so this is how hub operates. You need to pay attention here. That's where I'm trying to go into. The operation of the switch will be different from the operation of the hubs. So the operation wise is different. Huh? So here the hub will transmit the received signal into all ports. Yeah, all ports. It's simply like broadcasting to all ports. Hey, I have a message. That's how hub works. You see, so you have 4 points here. Let's say you want to answer a question in the exam. So if you go and explain clearly, point by point, I can easily see that you can get 8 marks here, easily 2 marks for each point, or 3 marks for each point. You can easily collect 8 to 12 points. So that's how the question papers will be set. They will set one question and they will give you 15 marks. So how to get 15 marks? This is how you answer. First, the signal comes from one dedicated devices, and one particular port will receive it, receive the signal, clean it, filter it, regenerate, and then retransmit to all the ports. Yeah, to all other ports. And also you can talk about hubs and network bandwidth. So this is where you need the knowledge. Huh? If you know all the terms related to network, you can really write such a good answers. Hubs share bandwidth with all other connected computers. That is a keyword. Huh? That is the keyword that I wanted to share with all of you. Amount of data that can be transferred in an interval is what we call bandwidth. Bandwidth is basically traffic. Traffic. Amount of data. And the keyword here is hub shares bandwidth. So when hub shares bandwidth with all other connected computers, remember it transmits to all ports. Only one computer can successfully transmit data at a time. This is also another point. One computer only can transmit at a time because they are sharing. They are sharing the bandwidth. So what is bandwidth sharing? When all computers connected to the hub must share the amount of bandwidth the hub provides. Remember I told you, if each port provides you 10 Mbps, and if there are 5 computers, you take the 10 Mbps, you divide by 5. So each port or each computers, the speed will be 2 Mbps. This is the keyword that I want you to understand. If the speed of the hub is 10, and if there are 5 devices connected, you divide the 10 by 5. So each computer will get only 2 Mbps. And let's say one computer is shut down, 4, then you divide the 10 by 4, 2.5 meg. That's how it works. That's why you see the traffic will go up and down, or the bandwidth will go up and down if you use hub. It will be completely different if you use switch. Hub can only operate in half duplex mode. That is another key point. Remember the mode, transmission mode, simplex, half duplex, or full duplex. So hub only can operate in half duplex mode. That means either you transmit or you receive. Cannot be both at the same time. Either you transmit or you receive. Cannot be both at the same time. That is half duplex. I hope all of you still with me and you are following me. Next week, when I see all of you, I'll refresh what is simplex, half duplex, full duplex, or duplex, and how hub operates. Because why I'm stressing, reason, this is how EOG will set question. They will ask you to compare hub and switch in terms of operation. What are the differences? Remember, I give you one example. If the speed of the hub is 10 Mbps and you have 5 computers connected, the speed at each end will be 2. If you pull out one computers, become 4, the 10 will be divided by 4. So each port will get 2.5. That's what we call bandwidth sharing in hub. Okay, I just want to introduce Ethernet switches before I stop for today. Before we go into further discussion, I want you to understand hub first clearly, and then I need to stop and go for my meeting. But before that, let me explain to you Ethernet switches. Ethernet, Ethernet uses star topology. Hubs uses bus topology. And Ethernet or Ethernet switches, as you can see, able to set up direct connection between any two nodes. So it's not like one device send a signal and then it broadcasts to all the ports. No, switches is dedicated. If I send A to B, it goes only to B. If A to Z, it goes only to Z, not A to all. That's another difference between hub and switch. Multiple pairs of nodes can communicate at full bandwidth. Twisted pair cable is UTP cable or STP cable. So unshielded twisted pair or shielded twisted pair. UTP is unshielded twisted pair. STP is shielded twisted pair. I'm not going to tell you what is the difference between UTP and STP. All that are basic, but shielded or unshielded, both are twisted. So twisted pair cable, or we call it UTP cable or STP cables, are normally used for switches, and it's being used even now. The difference is only either you use old cable Cat 3, Category 3, Category 5, 5E, or 6 or 6E. The higher the number, the better the performance of the cable, isn't it? And it is more expensive. And in your wired local area network is what you use twisted pair cable. As you can see in the diagram in my slide, you have 4 computers, and each computer has its own dedicated port connected to the switch. So if you have a signal from computer A that you want to send to B, the signal will travel A to B, because there are a lot more that we need to discuss for this to happen. And also you see it is also work based on MAC address, IP address, that we can discuss further in our coming lessons, so that we understand clearly how switch works and how differ it is from hub, so that we have better understanding. All right. But for today, what I want you to know is, for those who have forgotten about what is hub all about, or never heard about hub before, never seen any hub before, I'm very sure in the house, in your house, you have 1 or 2 hubs that you have purchased it earlier. Otherwise, you can just go to any computer shop, Lawyat, or even in Penang, or even in Subang areas. Take a look at hub, or you can even go and browse from the internet how the hub looks like. It is a very simple device that you don't have to configure. It just requires you to on and plug and play, compared to switches, which requires configuration, which requires setting, which requires a network administrator to do some setting. It is not plug and play. It won't work plug and play. It has software or firmware that we learned from earlier section of these lectures built in, that you need to configure, and it is being loaded onto a flash card or onto a card that is built in the switch, that requires configuration, requires setting. That's why the details are getting slightly more complicated, where you can see MAC address, you can see IP address, you can see protocol, you can see setting, you can see configuration. So all that requires some understanding, and requires a person who understands network, so that to make this topology works. That's why switches is users star, reliable, dedicated, better bandwidth, better performance, more expensive than hub, and it is being used until today. Of course, there are a lot of improvement have been done in terms of switches, which we can discuss further in the next lessons. And also the speed of the switches, or the box switch, has tremendously improved, which can support gigabits, fiber network, and so on. All right, guys. With that, I don't want to go into the operation of the Ethernet switch for today, because it is even more complicated, and it will take more times to discuss. Anyhow, we have covered almost 43 slides today. As you can see, the number of the slides are down there. I hope so. We have covered quite a number of slides, maybe not 43. But There are a long way to go. There are a lot of topics that we need to discuss. So my suggestion is for those who have forgotten or still not very sure, I really suggest you to go and do some self-study, refresh yourself before you come back to my lecture next week. And with that, like what I said earlier, I have meeting, and the same goes to other heads. They have meeting at 4:30. Let's take a break, short break, and then you all switch your mode to local tutor and start your sessions even earlier or at 5 o'clock with your local tutor. With that, I'll talk to all of you next week. Yeah, next week. Next week, same time, same link. Okay, before we stop, any question?